Going to get back into a little bit of geometry today, and lesson 95 deals with the slant heights of pyramids and cones. First of all, let me show you what a slant height would look like. Here's a cone. The height would obviously go down from the tip to the middle of the base and meet it at a right angle. That would be the height. The radius would be from the center out to the edge of the base, and the slant height would be from the vertex up here, the tip, down to the edge of the base. That would be the slant height. So hopefully you see how we're going to be dealing with right triangles today. So first of all, let's describe the difference between the height of a cone and its slant height. Kind of just showed it to you in a picture, but now we'll put it in words. Height of a cone is the distance from its, here comes a big word for you, actually it's a small word, but apex, that's that vertex at the top that I drew from the height, from its apex to the center of its base. That's the height. As opposed to the slant height, and the slant height is the distance from its apex from the apex to the edge of the base. All right, so compared to the height of a pyramid, the slant height of the pyramid is always what? Well, if you look back here at this original, is it longer, shorter, or the same? If you look back here at this original picture, the slant height is always the hypotenuse of that triangle. Sorry. It's always the hypotenuse of that right triangle. So compared to the height, the slant height should always be longer, because slant height is the hypotenuse of a right triangle. And the hypotenuse of a right triangle is always the longest side because it's always across from the biggest angle in a right triangle. So the slant height is the hypotenuse of a right triangle, while the height is a leg. Hypotenuse is always the longest side. So in these problems, we're going to find the slant height, and to do so, we're going to sketch a right triangle to show the dimensions that we're using for our calculation. So on example C here, there's our height, and we're going to make a right triangle out of that so that we can find the slant height, which comes right down there, down the middle of that triangle. So that would be 8 high, because it says 8 right here. It's going to be 4 wide, because it's 8 wide totally, and we only need half of that, 4, and we're trying to figure out the slant height. I'm going to call it C because it's the hypotenuse of a right triangle. So we're going to do 4 squared plus 8 squared is equal to C squared. That's the Pythagorean theorem. The right triangles. That would make sense. So the slant height here would be the square root of 80, which 80 is divisible by a perfect square, 16. So we'll call the height, or the slant height, 4 times the square root of 5 centimeters, which is about 9 centimeters. And for D, let's do the same thing here. Let's sketch our right triangle. It is 6 tall and 2 wide. Where did I get the 2? Half of 4. So the whole diameter is 4. That means the radius would be 2. So that's where my 2 is coming from. So we're going to do 2 squared plus 6 squared is going to equal the slant height squared, because the slant height is the hypotenuse of the right triangle. So that'll give me 4 plus 36 equals c squared, and 40 equals c squared. So c is the square root of 40. Obviously, 40 is divisible by a perfect square, 4. So we'll simplify the square root of 40, and we'll make it 2 times the square root of 10, which is about 6.3 inches. So it all kind of depends on how we want our answer. Do we want it exact? Well, the only way to express it exact is by using an irrational number like the square root of 5 or the square root of 10 over here. But if we just want it rounded, we can just do 4 times the square root of 5, or take the square root of 80, and it's about 9, which we know because the square root of 81 is exactly 9, so the square root of 80 is going to be about 9. Okay, and the square root of 40 is 6.3, or about 6.3, and that makes sense because 6 squared is 36 and 7 squared is 49, and 40 is between those two numbers. So that's all I've got for you today. Not a lot on slant height, just being able to see it as the hypotenuse of a right triangle, and then we've got all the skills to be able to take it from there. So I'll see you tomorrow.